Physics Blender. I love 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 Physics Blender. Subscribe for more videos.
Let's continue our classwork about thin converging lens, paper 1 for core and extended. We have question 4. Before we start question 4, I would like to tell you a statement which is very important about the location of the image and one of the properties of the image, that as the object is moved, okay, towards the lens, what happens? The image becomes bigger and further away. Okay, this statement is very important, so you can recall the cases where the object is located and you can imagine how the image will be formed, what are the characteristics of this image. Okay, and by the way, you have to remember that we have 4 important points to describe the characteristics of any image, which are location, orientation, size, and type. And this will be repeated many times during our classwork, homework, quiz, and assessment. Okay, so the word lost, we have here location, orientation, size, and type. What do you mean by location? Where the image is formed. Between F and 2F, is it in front of the lens, behind the lens, the distance between the image and the lens, and so on. Orientation, if it is upright or inverted. Okay, size, we have 3 options. Okay, same size, or enlarged, or diminished. Diminished means smaller. Okay, and type, we have 2 types, real and virtual. Okay guys, okay, back to our question. In which labeled position should the object be placed in order to produce a real image of the object which is smaller? Okay, since you need it smaller, so you will choose the location which is far away from the lens, because as the object is moved towards the lens, what happens? The image getting bigger. So in our question, you need the image to be smaller, so you have to choose the location where the object is away or far away from the lens. Okay, so the answer for this one is A. Is it clear? As you move the object towards the lens in this direction, you will find that the image obtained will be bigger. Is it clear? Okay. Question number 5. You have here thin converging lens and is asking you about the nature of this image and if the formed image can be received on a screen. Okay, you know that all cases of thin converging lens, we have real image for core. Okay, by the way, for extended, they have the magnifying glass, which is the only case for virtual. Okay, in our diagram here, the rays, they are real rays, not extension of rays. So when these real rays intersect, the image is formed. So it's a real image, not virtual. And you know that this real image can be received on a screen, like in case of projector. So the answer for this one is D. Okay. Okay. Question 6 also is very important. We have here screen. Once you see a screen and you see an image on a screen, so you know that the image is real, even if the question doesn't mention anything about the image is real or virtual. The screen and the lens are moved back and forth at a various focused image. Which statement is always true? So in this case, as I told you, that real and inverted are best friends. Okay? All the cases you can find that the image is real and inverted, real and inverted. So when you move the lens or you change the position, the location of the lens or the object, you will get all the formed image on the screen. They are real and inverted. What happened is the image could be smaller or enlarged, according to the location of the lens and the object. But in all cases, they are real and inverted. So the image is inverted. Okay? Okay, so the only property or the characteristics which change, in this case, if you move the lens or the object, is the size of the formed image on the screen. Okay, question number 7. Which labeled distance here is the focal length of the lens? Okay, according to the 3 standard rays, we said that the ray which is parallel to the principal axis will refract through the focus, right? So here we have this light ray parallel to the principal axis, and it will refract through the focus. So the distance between the optical center and this focus, so this point is the focus, so the distance between the optical center and the focus, this point is called optical center. Okay, so this is the focal length. Is it clear? So the answer is B.
Subscribe for more videos. I love physics splendor. I love physics splendor. I love physics splendor. I love physics splendor.